So we know when it comes to mass spectroscopy of organic molecules, we can get different fragments. But when it comes to our haloalkanes, something else is thrown in the mix here. And that's because our halogens have pretty distinct isotopes. So specifically, chlorine and bromine containing organic molecules do have multiple molecular ion peaks and fragments. And that's due to the fact that they have isotopes, and we know that chlorine and bromine have pretty significant isotopes. So for that fact, chlorine has got two isotopes, chlorine 35 and chlorine 37. Now they're in existence in a 75% to 25% ratio, or 3-to-1 ratio, whichever way you want to think about it, but I'm sticking to 75-25. And of course, bromine, another common compound, we're going to have 79 bromine and 81 bromine. Okay, so those are our two common isotopes of bromine, pretty much in a 50-50. Okay, there is another one or two bromines, but these are the ones we're concerned about, 50-50 as far as we're concerned. So if we take two simple halogen containing molecules, we've got ethane, okay, but with a chlorine attached. So that's chloroethane on the left hand side here. We're going to look at the mass spec of that. And on the right hand side, we're going to look at bromoethane. So both of these molecules are exactly the same when it comes to their carbon structure, but of course one's got a chlorine and one's got a bromine. So what do these mass spectra look like because of the isotopes? So again, I'm going to draw a couple of axes here, just like I did in the last tutorial. On the y-axis, we've got our abundance, usually a percentage, and on the bottom, our classic MZ value, so our mass to charge ratio. So let's start by looking at the molecular ion peaks. Well, of course, the molecular ion peaks, they're given by the entire molecule, the entire MR of this molecule. But the thing is, like I said in that opening statement, you can have, or we do have, multiple molecular ion peaks. So let's have a look at what we get in terms of chlorine. Now we're going to get two molecular ion peaks here. Why? Because we've got two isotopes of chlorine. The full molecule makes it through and gives us a molecular ion peak, but we've got different values for it because one of them contains chlorine 35, the other contains chlorine 37. So specifically, what's causing those? Well, the 64 is caused by the C2H5Cl, but specifically C2H535Cl. So that one chlorine atom that's bonded to that molecule is a chlorine 35 isotope. The 66, likewise, we've got C2H5Cl again, but this time the Cl is 37 isotope. So they're both the full molecule, but because chlorine's got two isotopes that have, a two difference between them, 35 and 37, you're going to get two molecular ion peaks. And of course, don't forget to put those pluses on the end of those. One important thing I'm going to point out here is the distribution, or the abundances of these. Don't forget, chlorine 35 and 37 have a 3-to-1 or 75-25 ratio. These peaks are going to be the same. 3/4 of our chloroethane is going to contain chlorine 35 because that's the relative abundance of chlorine 35. And this is going to be, 25%, or 1/4, if you like, is going to be chlorine 37. So just like we've seen in the mass spec of chlorine itself, looking at the isotopes, we're going to get the same distribution here. So what about the fragments? So we're going to get three different fragments here. Let's say if we broke that carbon to carbon bond, we're going to get 15, 49, and 51. And as I say, we're breaking this carbon bond here. So the 15 is caused by the CH3 close brackets plus, as 15 is usually caused by. On the other side here, though, we've got CH2Cl. Now again, because that Cl's involved, we're going to get two different peaks based on the two different isotopes. So the 49 caused by the CH2Cl35, the 51 caused by the CH2Cl37. And again, we're going to get them in the same relative abundances, a 3-to-1 ratio, because that's the ratio between chlorine 35 and chlorine 37. So the same thing applies absolutely to our bromoethane, but this time again, they're different abundances. It's a 50-50. So if we're going to get this bond here broken, then we're going to have a few different fragments on top of our molecular ion peaks. So I'm just going to draw all these out and then I'll explain them afterwards. So just like chloroethane, we're going to get 5 different peaks. On the right hand side, far right hand side, always our molecular ion peaks. This time we're going to get 2, of course, 108 and 110, because that's the full molecular mass of bromoethane. 110 contains the 81 bromine, 108 contains the 79, just in the same way that chlorine did. But this time it's a 50-50 split. They're going to be the same height. Now, when it comes to the split down the middle, we're going to get a CH3 plus at 15, standard, and then the rest of the molecule on the other side of things. So CH2, 79 Br plus, that accounts for 90, the 93 peak, and the 81 bromine containing version, that's the 95 peak. And again, you will notice that those peaks are the same height because bromine, those 2 isotopes of bromine have equal abundances. So those fragments of the bromine containing compound will have equal abundances. So in summary, well, 2 points here. One is that the molecular ion peaks and the isotope containing fragments must contain the isotopic mass of the halogen. So if you're ever looking at, the fragments and you're thinking, oh, it's kind of worn out or can't figure out where it's come from, it's probably down to an isotope of chlorine or bromine. Abundances of peaks mirror the relative abundance of the isotopes. So you've got a 75-25 split of chlorine. Any chlorine containing molecular ion peaks or fragments are going to have that ratio as well. Same with bromine, it's a 50-50 bar any of the tiny ones that we've got present, okay? So 2 really important facts here. So when it comes to halogenoalkanes, okay, what we've got when it comes to mass spec, look out for your multiple ion peaks, okay? So when it comes to your molecular ion peaks and your fragments as well. Like I said, include the 35 and 37 for chlorine, 79 and 81 for bromine, which is really, really important to distinguish the 2 apart. And again, the mirror of the relative abundances in those peaks for fragments and for your molecular ion peaks.